So which one is this?
After doing the 2 labs the last 2 days, all of this material should make perfect sense. That's the point of doing something before you learn it. All right, so in this lab, or in this demonstration of Boyles' law, we're going to compare pressure and volume. So, what happens if you squeeze something? That means the volume is what? Increasing or decreasing? Decreasing. Okay, so when you squeeze that thing, the volume goes way down. What can you say about the pressure inside the syringe as the volume is drastically lowered? Absolutely. Which means that we now fully understand Boyles' law, which states that volume and pressure are inversely related. Okay, so if I wouldn't have put you through those 2 exercises and I just walked in one random day and I said, hey, don't forget this, volume and pressure are inversely related, you would be like, all right, Miss Walderman, I'm out. Okay, but now you have something to go back to. You have an experiment to remind you that the smaller a volume gets, the higher the pressure. And you can show it graphically like this. Is there a positive slope or a negative slope? Why? Because it's a what relationship? It's an inverse relationship. Okay? This is the only one that's inversely related. All the other ones are direct proportions and they're very easy to solve. This is the only one that's inversely related. All right, can I move on?
Yes.
All right, sweet. There's also another law in chemistry called Charles' law, and this is asking you how volume and temperature are related. Okay, so yesterday I showed you this in the form of an ice bucket. So what is ice? That means a very what temperature? Low. So think about low temperatures, cold things. What's the volume? What happened to that balloon yesterday? It shrunk. It got smaller, right? Which means that low temperatures will decrease the volume of a gas. Agreed? All right, so here we go. So since those arrows are both going in the same direction, what kind of relationship is this? Direct, which means I can set up a proportion. Volume and temperature are directly related. Easy enough? Okay, what about really warm things? They get bigger. Okay, because the arrows will always do the same thing. It's a direct correlation. All right, and then finally, this was the 3rd principle from yesterday, which was Avagadros' principle, which talks about the number of particles. Oops. The number of particles. Which is also called the what of gas? Moles. Whoa. Okay, so if you put more and more and more and more particles inside of a balloon, what's going to happen to that balloon? It's going to get bigger. So you could say that the volume also, what? Increases. Okay, so one more time, direct or inverse? Direct, which means if one goes up, the other one goes up. If one goes down, the other one goes down. Agreed? All right, volume and number of molecules are directly related. So think back on that graph, because I'm really stressing the graph because those are test questions. On a direct relationship, is the graph going to go down or is the graph going to go up on a direct relationship? Yeah, absolutely. This is the graph of a direct relationship. All right. Which means that you can set up a proportion and it's really easy to solve. All right, finally, there is a combined gas law, which was the fourth activity. I said use your brain and try to come up with a common gas law. Oops. Okay, so here are the three that you're working with. You have PV equals PV. You also have V over T. You don't have to memorize these because they're given to you. And you have V over N. But how can we create a common law out of those three things? Yes, he's exactly right. He said PV over TN. Okay, where should the P's and the V's always be? Next to each other, right? But what about V and T? Where should the T go? Below it. Perfect. And below it, do you see how I combine those first two together? There's still another thing that I need to combine in there. So if V is on top, where does N go? On the bottom. Perfect. So here's what we call the combined gas law. It's going to take all of those things and it's going to throw them together. Are you okay with that? All right, awesome. So now at this stage, I have finalized our unit. And that unit is on this blue piece of paper. Take a look at this blue piece of paper. All right, and right here are all of the gas laws that you're ever going to have to use. Right there, okay? It says that the behavior of gases is described in these different ways, okay? PUV-NERT, have I taught you PUV-NERT before? PUV-NERT, have you ever heard that?
Yep.
Yes, absolutely. Yesterday, we learned about all the different relationships. So those are right there. So all of your equations will always be given to you. Now it's just a matter of using them. And it's really not that difficult. So let's get into the in-class practice. All right there. Okay, this is where we're going to start practicing these gas laws, and we're going to do the math. Okay, so in-class practice, use your formula sheet to solve the questions. Pretty straightforward. Okay, the first thing that I want to do is identify what variables are given. Okay, these are the variables that are given. Okay, what does 14.5 tell you? How do you know? Because it's 14.5 what's? Liters. Okay, so there's one variable in the problem. It also gives me 146.4.
What is KPA?
What is KPA?
Pressure.
It's a measurement of pressure. You're exactly right. Okay, there's also another number in here, 120.5 KPA. So what does the problem give you? Another what reading? Another pressure reading. And then it says to what volume? Okay, have I lost anybody yet? All I did was circle numbers and try to figure out what variable they were. Okay, so now at this point I need to go find an equation. Look at those 6 equations and one of them only has P's and V's in it. Which one only has P's and V's in it? Pressure and volume is equal to pressure times volume. Do you see that equation?
Isn't it Boyles' law?
Boyles' law. You're exactly right.
Volume and pressure are inversely related.
Okay, this is Boyles' law. And he says that volume and pressure are inversely related. So what happens to the pressure? Does it go up or down? The pressure went down. Okay, so I'm going to think about this. How do you get pressure to relax a little bit? What do we do with volume? You increase the volume, right? Because these two are inversely related. If this goes down, that's got to go up. Well, let's figure it out. Let's see if it goes up. All right, put this in your calculator. 146.4 times 14.5 is equal to, what numbers go on the other side of the equation? 120.5 what? X. You got it. Okay, let's solve for X and see if, in fact, the volume goes up. How do I solve for X? Times those things together and then divide by 120. All right, so multiply this and then divide by 120. It turns out that your calculator will give you a new volume.
Wait. Alright, no, I got it.
Okay? Yeah, I heard somebody say it. What is the X value?
17.6.
Absolutely. Yeah, absolutely. Why? Because with the volume getting a little bit bigger, what does it allow the pressure to do? Go down, right? Less pressure. Okay? So that would be an example of Boyles' law. That's exactly what you did yesterday. If you start at 14.5, you have a certain pressure. Make it bigger and your pressure goes down. Agreed? All right, let's try it again. Here we go. Question number 2. What do we always do first? Okay, I really want to cue in on the numbers. And I want to figure out what the question is asking me. So let's start by circling those numbers.
Put it in Kelvin, so add 200.
You are correct. We'll get there in a second. 4.0. Volume. So this question is comparing volume, and it's also comparing it to degrees Celsius. What is degrees Celsius going to tell us? Perfect. Yes, thank you. That's the second person that said it. That's awesome. You guys are totally remembering that we need to add 273 because we're not doing degrees Celsius. We want Kelvin. And the question says to what volume? So that's your next X variable. And we have a second what also listed? We have a second temperature listed. But we don't want degrees Celsius. Leah's going to tell me what I need to do to degrees Celsius.
You need to add 200.
Faux show. All right, think about it. What kind of environment are they moving it to? From 104 degrees down to 27, right? So what are we already expecting? When things get colder, the volume should what? It should get smaller. All right, let's give it a shot. Did we find our formula on our formula sheet? Do you agree that this is the formula that we're looking for?
Charles's law.
It is Charles's law. Thank you.
How are we supposed to remember all these different?
The good news is you don't, because you're going to get that blue piece of paper on your test. And I don't think there's actually a question that says state Charles's law, because it's not given to you on the resource sheet. But it'll be like this. Circle the numbers, identify the variable, and then pick an equation. Here we go. 4 over, what are those two things when you add them together? 377.4 is directly proportional to X over 300. Do you know where I got that 300 from?
27 plus
273. Okay, so at this point it's just like a proportion. 4 over this is equal to X over this. What's happening to the temperature? It's getting smaller, so we're also expecting the volume to be shrinking as well. All right, cool. Yay, I love proportions. What do we do with this? How do we solve a proportion? Cross multiplying is my favorite thing to do ever. Even more than anything you can think of. I would rather cross multiply. All right, so what do I put in my calculator? Yeah. Multiply the first two. Multiply 4 and 300, and then divide it by 377. Does the volume decrease also? What is the volume? 3 point what? Cool. Okay, gas laws aren't hard. It's just a manipulation. It's like if you move something from one environment to another, what's going to happen? 3.18? Okay, so somebody put the top and the bottom down, or you guys put the top and the bottom. 179. Okay, so if you got 3.75, it's because you put 377 as the numerator, and 377 should be the denominator when you're dividing. Do you know what I mean by that? You switched them. $3.18. Yeah. Are you with me? Okay, multiply those two and then put 377 on the bottom. All right, awesome. Here we go. What's this first step? What do I always do first? Circle them, right? Because I want to think about what equation to use. Okay, a cylinder of gas has a volume of this and a pressure of this. What would the volume be if we made the pressure up to 238? All right, so let's write it down. What does 97.64 stand for?
Volume.
Perfect. That's volume because it says milliliters. What does 94.4? Perfect. Pressure. What's the question at hand? What's the volume? Perfect. And then they finally give us another KPA. What is KPA going to tell us again? Pressure, 238.8. Have I lost anybody yet, or are we at least good enough on this step? Perfect. Now that we have everything circled and labeled, now let's look for the equation that applies. Boyles law again, which says that volume and pressure are inversely related. So that's this equation, right? Yeah?
Yeah.
Easy enough. The first V, what do we put in? The P is 94.4. And then 238. And then X. Did I write it down wrong? 238.8. Oh, I see what you're saying. It can go frontwards or backwards. It's a commutative property. All right. I already know in my head that if the pressure is going way up, that means the volume must be getting what? Lower. Okay. I already know that in order to make this pressure so high, I have to squeeze it. So hopefully my answer comes out way less than 97. Let's give it a shot. What's the answer? Anyone? 88.6. 38. Okay, so multiply those first two. Let's start one step at a time. Ooh. Multiply 97.64 and 94.4. And then go divided by 238.8. Correct answer is 38.5 or 0.6. Yeah. You're out of here? Okay. Are we good with the easy questions? All right, these are the easy questions. Number 4 and 5 are going to get a little bit more difficult. I'm just going to work those two out, and that's probably all the time that we'll have. So let's go through number 4 and 5 real quick because they're harder, and I want to be able to support you. And then after that, we are done. Oh, yeah.
I'm so sorry.
What just happened?
I slapped a little bit. I threw this balloon. I was like, hey, throw this away.
And then it got stuff all over her face.
Terrible.
You should. That was awful. I'm recording this, and Graham just slapped Natalie in the face with a wet balloon. My class is awesome. Yes. All right, here we go. Step number 1. What do we do? Circle them and label them. A certain gas occupies this at this and this 38. What is the correct volume at standard temperature and standard pressure? This is why it gets a little bit more complicated. So if you've zoned out, zone back in for a second. Got it? Okay. Let's start with the 68. That is a volume. The 19 is a temperature. And the 7.53 is a pressure. Agreed? All right. The other side of the equation. What will be the volume? So there's your X.
Wait, so wouldn't you still do 2 plus 273?
But what is standard temp?
0
It's just 273 by itself, or 0 degrees, which is whichever way you want to think about it. If you forget, it's on your pink paper.
So that's 0
Uh-huh.
Kelvin?
It's 0 in degrees Celsius. It's 273 in Kelvin.
Yeah.
0 Kelvin doesn't exist. That's absolute 0.
Alright.
That's like negative 200 degrees, which is really cold. Like really cold. Mm-hmm. Yeah, that's the temperature at which all particle motion will stop. Standard pressure, though. Standard pressure in kilopascals is something else. Look on your sheet and see if you can find standard pressure in kilopascals.
What?
Okay, what is exactly right? Why did I write 101.3? Okay, it obviously says that standard pressure is 1 atmosphere. Why would I write 101.3? Because kPa is different. Okay, so about 3 lines down, you see that 1 atmosphere is the same thing as 101.3 kilopascals. Make sure that you use the same units. This is a kilopascal. And this is a combined gas law. PV over T is equal to PV over T. And that's when life gets crazy. Unless you're a rock star, in which case this is not crazy. All right, let's try to plug stuff in.
Hopefully there won't be too many people that play.
There will be. That's the problem.
A lot of them.
Probably 2. That'd be my guess. All right, pressure. What do I plug in for the first P?
292.
That's the first T. The first P is 7.53 and the first volume is 68.4. Agreed? And divide that by your temperature, which is 292. Have I lost you yet? No, 292 is the Kelvin scale.
What were you 292?
Oh, I did 19 plus 273. Do you know why I did that? Because we got to convert to Kelvin. The second pressure is 101.3, and then there's an X over there also. And the second temperature is 273. Do you see that? So you have all sorts of variables working against each other. The problem is actually solving for X. From your math class, do you know how to solve this problem?
Yeah.
Good. Okay, you want to give it a shot on your own, or should I walk you through it? Okay, I'll give you a hint. It's got to be, sorry, I'll give you a hint. It's got to be all of these multiplied, and then all of these multiplied. That's going to be the first step. That's your hint, and then after that you can work to solve for X. But simplify that big, complicated proportion first. Can you check it? Yeah. Yes. I believe that is correct. Yes, sir.
So you would just do that, that way or something?
You could do that, and then you would have to do this number divided by that number.
Oh, then what I get from that divided by 270, by 103 or 2?
Well, you have to simplify that and simplify that, and then you could solve for x. Okay. Yeah, there's several ways that you can do it. I don't know which way is your favorite. Another thing that you could do is simplify both sides and then solve for x, which means do all of this math and then do all of this math. I'm going to stick to cross multiplying because I like cross multiplying. What?
Like something like that, or
Something like that.
where you like divide by 273.
Multiply by 273? Oh, yeah.
Yes.
Multiply.
Yes.
Yes.
Okay.
Yep. That'll work. Okay. In the end, your answer comes out to be, did anybody get a good answer? Yes.
I don't know if it's about 4.7.
Awesome. Okay. Whichever way you went to get there is fine with me as long as you know what you're doing. If you don't know, I would stick with cross multiplying, which means multiply those three. These three first. And then those two afterwards. And then divide the first one by the second one. That's how I would do it. 4.75. All right. One more just for practice sake because this is so fun. All right, here we go. Why? But it's easy.
It's just long process.
I mean, it's okay.
No. This is the easy stuff. Stoichiometry is hard. This is no stoic. You thought easier than this? No. No, this is awesome. You circle, you label, you plug in, and you solve. It's like heaven on earth. Combined. Combined gas law. All right, here we go. Last time, and then we're done. All right, the first one, 69.4. What is that a measurement of? Volume. And how do I know that? Because it says liters. Okay. 106 is a measurement of temperature. And 58.83 is a measurement of pressure. Now, once again, that's in kilopascals, and that's important because in a second they're going to use STP. Okay, so what will be the volume at STP? STP means the standard temp and the standard pressure, right? So what was the standard temp?
106.
No, the standard temperature in any problem is 273, perfect. And the standard pressure in any problem for kilopascals is 101.3. It's really not that bad. You guys are treating it worse than it is. I can show you. So this is going to say right here standard temperature and pressure, and it's going to tell you 1 atmosphere, but unfortunately we don't want atmospheres. 1 atmosphere is the same thing as that many kilopascals. Okay, so set up the entire equation. You'll see that this is another combined gas law equation because we have all of those variables shoved into one problem.
Is it?
If there's no N mentioned, then you can just ignore the N. But all the other ones are combined gas law.
Is it?
Yeah.
Combined? Yeah, it's combined gas.
Yeah, it is. What's up, Austin?
Can you tell me if I set this up?
Yeah. 106, there's a problem. What do I have to do with the 106? I have to add 273 to it. Don't forget to convert to Kelvin. 379. Yes. Yes.
Multiply, divide, and then simplify this one, and divide that.
Multiply, and then simplify that one.
Simplify the big one.
I would say, if you wanted my advice, I would say this 3 cross multiply, and these 2 cross
Oh,
multiply,
and divide up.
and then divide them out at the end.
So that makes it easier.
Yeah. Okay, one more time. My advice is those 3 get multiplied, and then those 2 get multiplied. And now I can do the first one divided by the second one. Okay, so multiply, this is cross multiplying is the easiest in my opinion. Either way, you'll come up with an answer. Does anybody have a good volume for this, the volume of this gas at standard temperature and pressure? 29.0. Can anybody verify that?
29.029.
Perfect. Got it?
29.
29. Faux show. All right. All right, guys, go ahead and pack it up. You don't have to think about this again until Monday night, in which case you'll practice one more time.
Tuesday night.
No, Monday night. It's due Tuesday.
We don't have school Monday.